welcome to calculus.
All right, so here we have n is less than 2 to the n. For all positive integers, this is what you have to prove. And it doesn't take much to convince yourself that that's true, right? Any number is less than 2 to the power of that number. But let's just try it for n equals 1. And we get that 1 is definitely less than 2 to the 1. Okay? It even works for n equals 2. 2 is less than 2 to the 2. All you have to do is n equals 1. Okay? I just did that one for an extra response.
Doesn't it work for any integer?
Yes. We're going with this. Okay. So the n equals k case, right? It's just k is less than 2 to the k. And if we're talking about all positive integers n, okay, then we're going to say that this is true if k is greater than 1. K is greater than 0 doesn't give us much information. We're going to go k is greater than 1. And you'll see once I'm done with this why we do it this way. So that's the k step. Now, what about for n equals k plus 1? Just like the ones for the divisibility, we're going to build up to that. So for the n equals, in order to get n equals k plus 1, we're going to build up to it. So we have what we started with here. K is less than 2 to the k if k is greater than 1. Now, I'm going to take this, and just like I did with the divisibility, I'm going to multiply both sides by 2. Because I want the exponent of k plus 1. So now I have 2k equals 2 times 2 to the k. Well, the exponent of this 2 is 1. So this is 2k is less than 2 to the k plus 1. And I'm just going to pause there for a minute and move on to the other part. Okay? Now, what do I want? Okay? What do I need to show? Or what I need to show is this. I need to show for the k plus 1 case that k plus 1 is less than 2 to the k plus 1, right? Going with this, if n equals k plus 1, that's what I need to show. So now I'm going to work with this side. There's a reason why I have this there. I'm going to work with this side. So what I'm going to do is bring the 1 over. So now I have k minus 1 is greater than 0. Now, k can be written as 2k minus k, right? Minus 1 is greater than 0. So 2k minus k is k. I just rewrote it because I can do that. Now, what I want though is not, I want a k plus 1. So how can I get that form, a k plus 1? Well, what if I factor out the minus? Now I have 2k minus k plus 1 is greater than 0. Awesome, because this is all writing on that k plus 1. So I need to have it show up somewhere. I decided to write k as 2k minus k. What's 2k minus k? K. So it's like if somebody asked you how old you are, you can either say 17 or you could say 13 plus 4. Or, 20 minus 3. Okay?
If you say 20 minus 3.
Huh?
How did you get to that last?
I just factored out the negative and grouped it. Okay? So now I'm going to rewrite this as 2k is greater than k plus 1. All right? So now let's see what we have. Huh?
Oh my.
Now, yes. Now, I can switch the order here, right? So I can say, well, that's the same as saying k plus 1 is less than 2k. All right, now, I'm going to stop there. So I'm going to take the last step here and the last step there. And I'm just going to write them over, right over here. I'm just going to write them over right here, okay? So in the case of this one, I have that k plus 1 is less than 2k. And from here I have 2k is less than 2 to the k plus 1. Now, let's talk about the transitive property of inequality.
Oh, this is equal to that.
Right. If Josh is younger than Sarah, and Sarah is younger than Mrs. Malikian, then Josh is what compared to Mrs. Malikian? Younger than Mrs. Malikian. If this is less than 2k, and if 2k is less than 2 to the k plus 1, then that means that k plus 1 is less than 2 to the k plus 1. What did I want to get? Just this. Okay, so there you go. I proved it. Do you now see why I had to do all this? Right here? Okay?
This is made up.
Right. So, oh.
It's just like, how do you get these steps? How do you just decide that you're going to
Add 6K.
make K?
Same way the Beatles made.
Okay, so we're going to do this next one. It's similar. Now it's 2n is always less than 3 to the n. So for n equals 1, it's 2 is less than 3 to the 1, which is true. The n equals k step says 2k is less than 3 to the k, again, if k is greater than 1. All right? You need that 1 because you want to get k plus 1 eventually. All right, so for the n equals k plus 1 case then, okay, we take this and what do we multiply both sides of this equation by? Because we need to get 3 to the k plus 1. By what? By 3, just by 3. You always multiply by whatever the base of that power is. Well, to help guide us, let's see what we need to show. We need to show that 2 times k plus 1 is less than what? 3 to the power of what? K plus 1. That's what I need to show. So I need a 3 to the k plus 1 from somewhere. Okay, so this is now 6k is less than 3 to the power of k plus 1. Which, look, that's the right-hand side of what I need. I need to show something is less than 3 to the k plus 1. Okay, so let me just stop there and let me work on getting this part. I'm going to get this part from k is greater than 1. So what did I do to this in the previous problem? Right. K minus 1 is greater than 0. There is a whole other hand-waving technique here. Huh? For this one? Well, what I need is a 2 factor here. A factor of 2. So why don't we do 2k minus 2 is greater than 0. Multiply everything by 2. Okay? Now,
What is it minus 2?
I multiplied everything by 2. So now, how can I write this 2k? If I do 3k minus k, then I get that 3, which I don't want. See, like, I want a 2, so I want to keep things even. So why don't I do 4k minus 2k? Okay? So what I have now is 4k minus 2k minus 2 is greater than 0. Now, I need a 2 times k plus 1. I can totally get that from here. Because look, this is 4k minus 2 times k plus 1 is greater than 0. Okay? So now why don't I take this over there? So 4k is greater than 2k plus 1. Let me switch the order because here the 2k plus 1 is on the left side. So why don't I switch the order? 2 times k plus 1 is less than 4k. Okay, I have what I need. I have 2k plus 1 is less than something. And I have 3 to the k plus 1 is greater than something. Why don't I write these next to each other and see exactly what it is that I have? What I have is that 2k plus 1 is less than 4k, and 6k is less than 3 to the k plus 1. Now you can either reason this out, or you can add another step. So let's talk this out. This is less than 4k. 4k is less than 6k, right? And 6k is less than 3 to the k plus 1. So 6k is less than that. I'm sorry, 2 to the k plus 1 is less than that. Okay? So we can add another step here, an additional step that says, oh, by the way, everybody knows that 4k is less than 6k, right? So now 2 to the k plus 1, 2k plus 1 is less than 4k. That's less than 6k. That's less than this. So 2k plus 1 is less than... There you go, which is exactly what I needed. Happy face for that. Okay? So it's like there is another person in here. Josh is younger than Sarah. Sarah is younger than Jacob. Jacob is younger than me. So Josh is younger than me. Okay?